Good, welcome back everyone at what is already our last track session of the first day. And for this last track session, I have a very amazing speaker, Animesh Rastogi, who is a technical account manager at Sears.Inc. And Animesh is an accomplished technical account manager who specializes in delivering highly intelligent solutions and offering valuable suggestions for technical enhancements. With expertise as a solution architect and Google Cloud specialist, he is not only a gifted external speaker, but a real thought leader as well. Today, Animesh is going to be talking about writing Kubernetes controllers with Golang. So I have to say that this is a topic of personal interest as well. So I really look forward to your session, Animesh. The floor is yours.
Thank you so much, Jan. Thanks for the introduction and welcome everyone. I know it was a tough decision between going towards the other session and coming here. I promise I'll try to make this interesting. The session primarily is pretty self-explanatory, right? Writing custom Kubernetes controllers with Golang. So here in this session, we are going to be talking about many things. Basically, we're going to look at what controllers are, what Kubernetes control loop is, how things work in Kubernetes, and how do you extend that, right? That's the entire point of having Kubernetes, is so that you can extend the Kubernetes control plane, leverage some of the best practices that the Kubernetes and the continuing Kubernetes industry and the ecosystem keeps introducing, and use it for your own requirements, your own application, your own automations, right? So that's what I'm going to be talking about today. So thanks, Jan, for a really, really good introduction. I'll also do a quick introduction of mine. So I work as a technical account manager at Sears. We are a cloud consulting and tech consulting firm. And I essentially work with all sorts of customers, primarily digital natives and tech startups in India, to ensure that their tech journeys are sorted in terms of stability as well as they are set for scalability, right? And of course, working with these startups, I see day-to-day on basis, based on different kind of tech culture, based on different kind of requirements that they have. It's very, very important for them to build in their own automations in existing technologies. Instead of reinventing the wheel, how about I customize the wheel to suit my requirements? And the great minds at Kubernetes who created Kubernetes, they knew something like this is going to happen. So that's why they made the Kubernetes API, the Kubernetes control plane, extensible as possible. So you can leverage the same goodness of Kubernetes and use it for your own applications. So today we're basically going to be talking about, I'll introduce and give you the context, which I have just did. Then I'll talk about what controllers are and what is the Kubernetes control loop. Obviously, I'm assuming here everybody who's joined has a fair understanding what Kubernetes is, right? And what it is used for. So I'm not going to dwell deep into that. Rather, I'll focus more on some of the aspects of Kubernetes which are leveraged when you try to develop your own controller or a particular controller. And what are some of the key libraries, since this is going to be a Golang specific talk, what are some of the key libraries that you use when you are developing your own controller? Then we'll look at a controller architecture, right? If you are going to develop a Kubernetes controller, what would be the architecture like? And when I say architecture, this is not a high-level architecture, this is a low-level design, essentially, as to you have a requirement that you want to set. Now, what are some of the steps? What are some of the key components that are going to be required when you want to build your entire Kubernetes controller in Golang? When you write that code, deployment and further, I'm not going to cover because that's a standard deployment for any cluster. And then we'll take a look at an example, and this is where we'll dive into the code a little bit. I'll also give you what example I've kind of used here. Then I'll open the floor for some Q&A, and then we'll get over and I'll give you rest of the day back. All right. So let's talk about the Kubernetes control loop, right? So as I said, Kubernetes is essentially designed to run your application and run them in a very, very stable and predictable manner, right? So Kubernetes design principle essentially was that once I've given you my workload, until unless there's some runtime error in my code, I want you to keep running it regardless of the infrastructure failures or whatever, right? That's what Kubernetes is. Essentially behaves like a endless loop, which basically tries to reconciliate the desired state with the actual state. So
Hi,
Kubernetes,
Animesh.
yes,
Your connection dropped for 1 second,
sorry,
and
apologies.
as a result, your screen is not sharing anymore.
Sure, I'll just share it again. Thanks for intimating, Jan. Yes, is it visible now?
It's coming up.
Sure.
Yes, there it is. Perfect.
Perfect.
Thanks.
Thank you. Right. So Kubernetes is supposed to be declarative in nature, right? So what does declarative software mean? Declarative software essentially says that instead of you fiddling about, how things are going to connect and how things are going to work, what declarative software asks you to do is you give me what you want in a particular templatized format, right? And then I will take care of all the internals of how to get to that state, right? So in Kubernetes, you create something called as Kubernetes manifest file. These are your standard YAML files where you define what containers to use, how much CPU and RAM you want to give to that, and you just provide it, right? You do a kubectl apply, or you do a you curl it to the control plane, or you use some sort of CD tool. But what happens is that manifest file is given to the Kubernetes control plane, the Kubernetes API, and then Kubernetes API's wheels start turning, and then it determines what is the current state of the cluster, and it does all it can to essentially reconciliate the desired state with the current state, right? And that's essentially what Kubernetes control loop is, right? So then what is a Kubernetes controller? So Kubernetes controller are essentially what the Kubernetes API uses. That's what works in the background to do all of this, right? That's what run the code to reconciliate, essentially. So if you think back to the Kubernetes architecture, what happens is Kubernetes API is the central hub where all communication is centralized. So all communication of getting or applying or updating, right, goes to the Kubernetes API, and then Kubernetes API uses all of these controllers in the back end to essentially do its tasks. So objects like deployments, pods, services, all of those have a controller in the backend, right? They keep running in the backend, and it's the controller that actually runs the code required to reconciliate. Okay, that's what a Kubernetes controller is. So Kubernetes controller is an endless loop essentially, right? It's nothing but a infinite for loop, which constantly keeps a watch on the API. As soon as there is a new object or a deletion request or an updation request that happens, it takes the new object or takes the new request in, takes a look at the current cluster, and reconciliates the state between current and desired, right? So just by talking, right, you would probably understand, okay, that's what a controller does. So I should be able to write my own controller, right? Because controller is nothing. What it does is it keeps it's a infinite for loop, and then once it receives something, it basically does some processing, which is whatever your controller is supposed to do, and then it applies it to the API, right? That's what it does. So these are the three broad aspects of a controller. So if you see in Kubernetes gives you something called as Kubernetes Controller Manager, right? Kubernetes Controller Manager is essentially that control plane which manages all of the different controllers that it has. So by default, Kubernetes comes with a bunch of controllers like deployment controller, as I said, right? Pod controller, service controller, ingress controller, and a lot of these controllers, right? It comes by default. And Kube Controller Manager is actually the process which runs this infinite loop, and these different controllers that you have, which are let's say Kubernetes default or your custom controllers, subscribe to this control loop, and they receive events through that. So this is what a controller manager is. Now let's talk about exactly what happens, right? I'll give you an example of a Kubernetes controller that we wrote for one of our clients, right? So what happened was I'm assuming everybody knows what Prometheus is, right? So in Prometheus, you define what is something called as a Prometheus.yaml file, right? That YAML file you define as a config map, and then the Prometheus server mounts that config map, and then loads all of the process in. But what our customer wanted was they wanted a platformatized Prometheus infrastructure, right? Where the platform or the SRE or the DevOps team is managing the Prometheus server, taking a look at this process, ensuring the process doesn't fail and it scales properly. But what they wanted to do was they wanted to democratize what metrics to scrape to all of their developers, right? So let's say if you have 5 teams, each team needs to monitor their own application. Each team needs to monitor, do it in a certain way. So while the platform team is managing the Prometheus infrastructure, they did not want to, wait for the application team, or the application team doesn't want to wait for the platform team to apply. They don't want to do a ticket-based approach. So what they wanted to do was each team can write their own Prometheus definition file, and then finally what happens is that some process builds a final Prometheus.yaml file from all of these different YAML files that the developers have written, and it automatically gets applied. So that's what the controller was supposed to do. So controller keeps a look at that custom resource that, hey, is a Prometheus template available? As soon as the Prometheus template gets available, what it does is it appends that configuration to the already existing Prometheus.yaml file and then restarts the server, right? That way, the ticket-based approach where the developer has to open a ticket to the platform team, hey, I need to scrape these different metrics. Can you please apply that in Prometheus? And that entire loop got closed, right? So that's what the control is supposed to do. And it made everybody's life very simpler. So if you see, right, in here, someone modifies, adds, or deletes a custom resource, which is Prometheus template in our example, controller gets notified that some changes happened via informers, and we'll cover what informer is. Controller gets notified notified that some changes occurred. What it does, it will put that in a queue. So it maintains an internal queue that to ensure that any changes that have happened are in queue, to ensure that there is redundancy and it is actually going to happen. It puts it into a queue, and then another process which runs as another go routine keeps popping that queue and actually processing that item, right? Which is essentially maintaining the or rather reconciliating the desired state with the current state, right? So the code that I was talking about, which is essentially appending it to the Prometheus.yaml file, actually happens in another go routine, which is the processing, right? And then the external world basically starts to look as desired. And in controller, you have an option, right? You have an option to continually monitor the API server, or monitor it once every few minutes or few time in a particular time interval, which is called the resync period, right? Now, as you can imagine, let's say you have a big Kubernetes cluster with about 50, 20, 30 custom controllers and then 50, 60 default controllers running, right? If you keep querying the API server every second that, hey, is there a change? Is there a change? Is there a change? Is there a change? Then you're gonna overwhelm the API server, right? So that's why what Kubernetes has done is that it has introduced a concept called informers, right? So what informer essentially is it is basically a shared informer or shared process. What it does is it basically makes a call to the API server once, gets all the details of the current state, and it stores into an internal cache called an index. Okay, so informers maintain internal cache, and it stores all of the current state of deployments, pods, whatever, right? Whatever that you want to actually take a look at, or whatever you want to actually use in your controller, whichever object that the controller is concerned with, it basically gets all of that, stores that into internal cache, and you can set a resync period that I want this cache to be renewed or refreshed every this minute or this time, right? That way you can ensure that your API server is not API server is not bombarded with requests, and it is not able to actually serve your business critical application. It is only going to get scaled up because of controllers, right? Because there's a cost aspect to it. And of course, you probably, so in most of the cases, 10 minutes is a good enough interval for you to keep resyncing your cache. So that's what informers and index is. So I'll just talk about this architecture really quickly, right? It looks pretty overwhelming, I agree, but bear with me. Okay, so what I've done is I've tried to ensure that this is step by step. You see what is exactly happening inside a Kubernetes controller. So this is all part of a code, right? It's not actually some component. It's everything is going to be a part of your code. So what happens is that, as I said, the Kubernetes API is something is happening. Let's say a deployment object has changed. Okay, what happens is that there's a reflector. What it does is reflector is essentially just before informer, and reflector keeps a list and keeps watching the server side Kubernetes API, and there's a, as I said, resync period, and it basically pushes it to a FIFO queue. Okay, and then the informer keeps popping that object, and then it adds that object into an indexer. That indexer is nothing but a cache, right? So it adds that object into a internal cache, and that internal cache is memory, right? It's in memory. Whichever machine that you're using, it's going to be in memory. Now what happens is that these informers have something called as event handlers. Okay, event handlers are nothing but on add, on delete, on update, right? So these are event handlers. If anyone's familiar with the front end JavaScript, you also have event handlers there, right? So it's kind of similar. On add, anytime an object is added to the indexer or deleted or update event comes, that event handler is triggered. Okay, these resource event handlers. Now you can choose to process that right there and then, but if let's say something happens to the controller, or if it's restarted, something happens, then you have some, you lose it, right? Essentially, or if informer restarts somehow, that process or that go routine somehow restarts, then there's a big problem, right? So what it does is, again, it queues that into a FIFO queue, right? It's called a work queue here. Anytime, let's say, a new add object comes, for example, in the event handler, what you do is you enqueue that into a FIFO queue, and that another go routine keeps popping those queues and essentially doing the actual process that needs to be done, right? So it basically handles the object, and once that object gets handled, it also goes and updates into the index so that the cache is relatively fresh as much as possible before the new resync period. So that's how the entire flow works. You have the informer, which keeps a check on the object. It queries the API server in a particular period. It adds object to an indexer, which is the internal cache. Informers are associated with event handlers. When a particular event handler is triggered, it pushes an object to a in-memory queue. Then another function which is running as part of another go routine. Please ensure that it runs as another go routine to ensure that all of these processes are happening concurrently. You don't want each of these processes to happen not simultaneously, but one after the other, because that would slow down your control quite a lot. So another one process is essentially keep pushing things to the queue, and another go routine keeps popping items from the queue and essentially keeps processing them, does whatever the controller is supposed to do, and then updates the object index. So that's how it all works out. I know it's a little overwhelming right now. It must be a little overwhelming. It was for me for sure when I first started getting into it. It was a bit difficult, but now I'm going to make you more overwhelmed because I'm not going to get into the code side of things, right? How does it actually comes together? How do you actually code all of these things out into your project? So before we go there, let's talk about some of the key libraries that are going to be used, right? So Kubernetes has a lot of libraries that it has exposed. So kubectl command line tool, it also uses these libraries in the backend. What we are doing is we are not using kubectl, we are using these libraries directly. So client Go is the most important library, right? Because it defines all of the, it defines the Kubernetes client, it defines all of the different methods and everything. Then API machinery. API machinery has all of, I would say, the API definitions or the variable definitions, right? In Golang, Golang is a very statically typed, strongly typed language, sorry, right? So all of the types are stored in API machinery. then APIs library essentially stores the methods and the actual APIs for different Kubernetes objects, right? So for if I give an example, let's say deployment, right? So deployment is part of apps v1 API. So all of that definition, everything is stored in the APIs library. And you can find all of them in GitHub, right? It's basically maintained under the same Kubernetes project, right? So you can find all of that in GitHub, and there are very good example folders in each of these repositories. So do check that out. Okay, let's talk about some of the custom controller examples. There's some of the very famous custom controllers which are out there. Think Istio, Prometheus, right? Istio and Prometheus, which are Argo CD, Aerospike, Redis, Postgres. So some of you may recognize some of these, some of you may not. But what these controllers essentially do is basically they define a fleet of custom resources, right? Like in case of Istio, you have virtual rules and basically all of that, right? Virtual rules, gateway resource, all of these different resources are defined. But anytime that, so Kubernetes doesn't identify virtual service by default, only because there's an Istio custom controller running, which is there to take action on that virtual service. Does it actually work out, right? So that's what Istio is there for. And there are multiple different controllers out there. So any sort of big project out there, right, which can run on Kubernetes would have a custom controller, right, associated with it. Okay, let's talk about this particular example, what we are going to look at in the code itself, right? So here in the code, what I've done is, for people who are familiar with Istio, in Istio, what happens is that you have to attach a label called app and the app name, essentially. The value should be app name to each pod which is under Istio, to ensure that you're able to route traffic well as to ensure that the virtual services are properly connected, and to ensure that it all looks very good or well in Kiali as well, right? Which is to visualize the entire service map, to visualize the flow of traffic and things like that. So what my controller essentially does is, anytime you apply a deployment object or update a deployment object, if an app label is not automatically present in it, what it will do is it will apply that app label to your deployment, or to all the pods that are created by the deployment, with the value of deployment name, right? So let's say you have applied a deployment called Nginx, for example. The name of the deployment is Nginx. So what it will do is, it for all the pods that are going to be part of the deployment, let's say if it's an HPA, then it will apply app Nginx to those labels, right? That's what my controller is going to do. It's a very simple controller, but as I said, I gave you another example, right? That's another example, automation example. There are many such examples that you can use, right? In a lot of cases, what a lot of customers have done is they have created their own self-healing databases, right? Or let's say if it's a very internal tool that they have developed, and they don't want to actually manage that tool like a black box, right? But they want to white box it. You can develop your own Kubernetes controllers and custom resources to ensure that those definitions are pretty clear to everybody in the company, right? So to begin with, you want to authenticate and create a client set, right? Before you even deploy any resource, or before you even work with, because as I said, right, the controller, all it does is interact with the Kubernetes API. So you need to authenticate, right? Now there are two scenarios here. Scenario number one, where the Kubernetes controller is running outside the cluster, in which it is supposed to work in, and scenario number two, where it is running inside the cluster, right? In most cases, what would happen is it would run inside the cluster, but it will actually manage multi-cluster operations, right? So in that case, both of this will work out, because what it will do, right? Obviously, you would be aware that Kubernetes uses kubeconfig files. So what here it is doing, right? It is basically getting the kubeconfig file from your .kube, which is your home directory. So it is assuming that the Kubernetes this controller is running outside the cluster. Okay, but if it's running inside the cluster, it will it will have an error. Then If the error is not equals to nil, then I will do an in cluster config and I'll get the kube config file from the actual service account associated with the pod that is running this Kubernetes controller, right? Then once I have got the config, then what I would do is I would build a client set. Now this client set is nothing but set of API rules. Okay, if you want to, let's say, get a deployment object, what you will do is client set.apps.v1.deployment, right? So client set is nothing but find the Kubernetes client that has opened up, and it has all of the methods and all of the different things, right? So that's what client set is. So now we have created a client set here. Authenticated using the config, we have created a client set. Now we are ready to interact with the actual Kubernetes API. Okay, now what I've done before even like doing anything is actually want to define my controller, right? So I want to define that controller as a struct itself to ensure that I can create methods on it, and I can actually pass it around multiple functions as variable, right? The current instance of controller. So as part of controller, I have given the variables as client set as one variable, queue. If you remember from the Kubernetes architecture, this it creates a FIFO queue, right, where all the event handlers will push their things, right? The informer, of course. So I've created a shared index informer and label key and label value as well, right, which is going to be the one attached to all of the pods that we have just talked about. Right, maybe a little unclear for you guys, so I'll just zoom in a little bit. Right, now here, what here I've done is I've defined a new control function. Okay, what this new controller function will do is it will actually emit out instance of this controller variable, right? Instance of this variable. So it's essentially like object-oriented methodology, right? Where if you do a new controller, so that's what the function is essentially. Okay. Now, if you see here, what I've done is I have initialized a controller, a controller variable with client set as client set, which we have defined in if you remember before. The queue, right? So this is the work queue type. Again, I'm not getting into the types here because these types are going to take you some time to actually get around, and you would have to do a lot of coding before you even get these types. You won't be able to remember this. Nobody has ever been able to remember all of this. But the good thing is if you're using VS Code or Golang, there's very good IntelliSense. So all of these usually get self-populated. Label key and label value essentially that I've defined up here. Now what I'm doing is I'm defining an informer. Okay, so what I'm here I've done is I've defined a new informer as cache.new shared index informer for apps.deployment, right? And then here, if you see, I've defined the event handler functions. Okay, so what happens? Resource event handler functions, add func and update func. So I've defined c.enqueue deployment. We'll see what enqueue deployment is, but you get the gist, right? What I've done here is I have enqueued the deployment here. And what happens when update happens, right? So it's a lambda function here that I've run, which will essentially enqueue the deployment. And then what I've done is here I'm returning the controller. So in the main function of our code, what I've done now, I have run C colon equals new controller, and the new controller essentially comes to and becomes that C variable, right? Now a controller has been defined, a controller has been initialized. Now what we want to do is want to run this controller. Okay. So I have created a new function here, which is now this is a method, right? So if you see here, there is func c star controller. So this will work as c.run essentially, right? Threadiness is essentially nothing but the concurrency, right? How many concurrent Go routines do I want to run? And stop ch channel struct. Now this channel, right? So again, I'm here assuming everybody has some intermediate knowledge of Golang before you came here, right? Because Golang is pretty critical here. Probably won't be able to understand much if you don't understand that. So what happens is that this particular channel is essentially used to shut down a the particular controller, right? So what I'm doing here, I'm running this controller, okay? Now, if you see here, this deferred wait until, what it is doing is it is running a worker Now this worker is nothing but the the another Go routine that I've talked about, which will run the actual process which will pop the queue, and it will actually process the items, right? So what will happen here with this function is that it will run multiple such Go routines here, and when there's a message that comes from the stop ch, as soon as there's a message that comes from the stop ch, it will stop the controller, right? So this is exactly what is happening here. But here, if you see, the stop ch is outside, so it will most likely never stop until unless there is someone basically gives it a what do you call it, a sig term or a SIGINT, and then it will stop. This is the run function. Now, as I said, right, here what it is happening is it is basically doing, it will run this worker here, and if you see for c.process next item and this. So what happens is that for process next item will return a bool, and as long as there's a true coming here, this will run as an infinite loop, right? Process next item, essentially what it is doing is it is getting an item from the queue, right? It is deferring queue.done. Once the function gets over, then it will this line will execute, right? And then it is essentially getting the number of items in the queue and processing that. And then if you see here, this is where I'm actually doing what I was supposed to do. So if you see over here, all of this code, everything till this point was just initializing and customizing a controller. The actual business logic, the actual automation that we want to do has come finally here as just one function with 20-30 lines of code max. The entire code before that was essentially nothing but the controller and all the process. Thankfully, what the Kubernetes community recognized is that, hey, every time they want to run a controller, they have to do all of this. It basically wastes your time, right? So what the Kubernetes community did was they introduced something called as the operator framework. Okay, the operator framework is essentially designed to be a combination of these controllers and custom resources, and it basically simplifies all of this process by doing code generation as well as templatizing a lot of things, right? So if you want to, let's say, write a new controller, all you have to do is you have to just worry about the business logic and write that as part of a particular function, and evoke that function in the main function. That's all you have to do as part of operator framework. So it's a very popular framework. You can just check that out on GitHub. Personally, I'm not a big fan of operator frameworks and tools which do code gen. The only reason being that obviously because they are a framework, they are less flexible in general, right? So you're not able to do a lot of things, right? So in our case, or in case of operator framework, you're not able to define the informer, you're not able to define the cache length and things like that, which are things you may need to tweak. So that's why I personally have not done a lot of coding with operator framework, but I have done some, and it's very good to get started with, right? Get familiar with all the concepts and then get into the coding for the actual controller yourself, right? Yeah, as I said, this is the in-queue deployment. Basically, it is nothing but doing a queue.add, right, for the key that you have. Right, so this was essentially my session. I don't have anything else. I understand this would have been a little overwhelming. I'm open to questions now. John, over to you. You can moderate the questions in case there are any.
Absolutely. Thank you so much, Animesh. I really like your presentation a lot. Goes into a lot of details. I invite everyone that has been listening in and that has any detailed questions for Animesh to ask them into the chat right now. While we are waiting for some of those questions that come in, I already see there's one in, and I also have one for myself. So let me first start with the one that has come in already. What are some of the common challenges developers face when creating these controllers, and how can these challenges be mitigated?
Right. So that's a very good question, and that has been my experience as well, right? When I was trying to learn Kubernetes controllers and how to write them, it was a bit of a steep learning curve, especially if you're not that familiar with Kubernetes and Kubernetes objects, right? Not again, assuming everybody here knows Golang, uh, it is going to take you. Personally, it took me about a month, right, to be able to actually nail down all the concepts because they look well in a diagram, but when you actually go and write that, it becomes really difficult. So the common challenges that I have faced essentially the a lot of developers and a lot of companies do not concern themselves with any sort of infrastructure based things, which makes sense, right? If you think from an average developer perspective, they're worried about which next JavaScript framework is coming up to be able to put their mind into some of these backend infrastructure things. So the biggest challenge that I face is not enough Kubernetes knowledge out there in the world, right? People just know how to use it, or they don't just know the basics of it, but not the deep end of Kubernetes because it is a very complicated topic. So that's my biggest challenge. So in my experience, what I've seen is most of the time these controllers and operators that have been written and developed are primarily done by the platform teams or by the DevOps teams to facilitate developer experience, right? So these controllers and everything are essentially a way to platformatize and improve developer experience.
Yeah, very good. So then I also had a question when I was reviewing the code that you showed me. If I'm correct in your definition, you might want to go back to the slides. I saw that the queue that you are defining
Yes.
Is in, as far as I could review it, is an in-memory data structure. Is that correct?
Yes, that's correct.
So that kind of brings me to the question: if that is an in-memory data structure, what's the risk of a memory overflow, or what is the capacity of the number of requests that you're going to be able to handle as a maximum, and how do you deal with high volume or high load requests?
Right. So this is in memory, yes. But think from a perspective of any node. Let's take an example of Node.js or any application, right? What happens when a request essentially comes in? When a request essentially comes in, there's a TCP connection that gets created between the client and the server, right? And it basically gets queued in memory, the actual connection requests as well as the different packets that you have as part of an in-memory queue, right? That's what happens. That's why you have things like
so you're using multi-threading. Is that the...
Yes. So my point is, instead of threading, right, this is going to be a common thing for across the development. So how do you manage for, let's say, outages, or how do you manage for scaling, right?
Yeah.
In terms of scaling, the simple answer is horizontal scaling, right? Instead of trying to vertically scale our controller, what we will do is we will put the controller as an HPA, and anytime take out the concept of scaling from the controller itself to, let's say, a service, or give it to the Kubernetes, right? So what will happen is, anytime, let's say, more than 10 requests are essentially there, another controller instance will come out and it will handle it.
Okay. So that is also because I did not see that part in the coding part, but that's implied that there's also horizontal scaling embedded. Is that correct?
Yes. That is something that you can't code. You have to define as your own scaling parameters and your own infrastructure layer, right?
Yeah.
So you do that at the infra layer rather than the application layer.
Okay. No, then I think we're completely on the same page.
Yeah, makes sense.
Good. Then we still have time for some other questions. Next one is around, let me show you on the screen. In what ways can custom Kubernetes controllers be used to automate scaling decisions, load balancing, and resource allocations? I think it's a little bit in line with my previous question.
Yeah.
Go ahead.
I'll just explain, right? So how can they be used for scaling? So one of my customer essentially doing, right? So what they have is a very nuanced scaling requirement, right? So they have a stateful application, so you can't auto scale them like willy-nilly. But because it's a Java-based application, you can't also vertically or scale them because of the JVM overhead. So what they have essentially done is use the Kubernetes controller to take in at least 10 different metrics in, right? So what the controller will do is it will every 10 minutes, it will take 10 different metrics away out from Prometheus, from the business layer, right? From a BI tool and all of the, from a data analytics tool. And based on those metrics, will it actually scale up or an application out, right? So that is why Kubernetes controllers can become really powerful, because out of the box you get only horizontal or vertical scaling, but sometimes they may not be required. That is one, right? In terms of, let's say, resource allocation, right? Again, as I said, you can do things like vertical scaling or horizontal scaling based on your specific requirements. So I'm not sure if you've heard, but a recent Kubernetes KEP has proposed, or not proposed, but in the recent Kubernetes version, you can upscale or downscale a Kubernetes pod in place without having to restart it.
Okay.
Think of the amount of potential that comes in, right? So where, for again, as I said, for Java-based application which has a JVM overhead, during startup it requires 2 GB of memory, but during runtime it doesn't need as much. So what you do is you run a Kubernetes controller and you take a look at its resource utilization a particular time and upscale or downscale that based on the requirement, right? And that would have a huge cost impact, right? It would improve your resource utilization, it would reduce your cost overhead. So these are different things. Again,
and this is already coming in the next version of Kubernetes.
Exactly.
Because I was not aware that is going to be included.
Yeah, it is coming. So there are very many different things that you can do with the Kubernetes controller. And as I said, if you are developing a new tool by yourself, Istio, Argo CD, or yada yada yada, or any internal developer platform that you have built, instead of deploying that as just a web application in a pod, what you can do is for the management and to democratize that, to ensure there's open sourcing within your company, you can create controllers for that, to ensure that they can also understand what is going on, because developers understand code, right? They don't understand all of the other things. So it's much easy for them to also contribute if it's code.
Yeah, no, I fully agree. Good. Let me go to the next question. I see the questions keep coming in, so let them coming because we have some time. I think you also already kind of answered this one when we talked about innovations, because you basically just mentioned a major innovation that is coming. Yeah. But the second part of the question I do think you can address is, how can developers start to prepare to adapt to these changes effectively?
Right. So personally, it is difficult, right? Again, as I said, right, if you're a full stack or a full-on developer, software engineer, then it becomes difficult, because the infrastructure space is a very constant innovation space. Kubernetes, again, as I said, right, you've just started to learn this, and then you realize a few versions ahead that has already been invented. So that was certainly my experience as well. I had written a Kubernetes controller and then realized, the next step has that same functionality. So I don't need to develop it anymore. Yeah. So how do you prepare yourself for this change? The simple answer is read, right? Follow some of the industry specialists, follow some of the industry engineers. Do ensure that you star these repositories. That is very, very crucial, right? The Kubernetes repository, the Prometheus repository, all the repositories that you're interested in, start these repositories and take active part in the issues and the conversation that is going on. The Kubernetes community is a very, very good community. It's a very inviting community. Their Discord, Slack, and they have a monthly meetup. You definitely would have a Kubernetes community chapter near you. So join that. So to prepare yourself for these changes, the simple answer is make your fundamentals strong and read. Right?
Yeah. So stay involved in the community. I think that's exactly. Very nice. Then I see another very good question, which is from a very familiar name. If I wanted to migrate container or VM data, do you know what kind of server downtime that would entail using Kubernetes?
Okay. Okay, depends on the kind of application that you have, right? Now that's a very architect level question. Okay, that depends on the kind of application that you have. If it's, let's say simple web server or simple stateless TCP HTTP based application, not that lot, right? I would say probably not much. Only the only downtime would probably result from the database rather than from the Kubernetes, because the app tier you can seamlessly cut over.
Yeah. So
The
you
only
mean in an active passive?
exactly.
Yeah, correct.
Exactly. You can do it in active passive, and then you can easily cut over. But the only downtime you would see is from the data tier, because obviously you cannot do the same with the databases. But in case this is a stateful application, right, which has data, which stores data in memory, Kubernetes is not well suited for such an application. It can do it. I'm not saying it can't do it. It's not well suited for such an application. But I know for a fact that many companies run huge Redis clusters, right? Huge Prometheus clusters on Kubernetes. So that is possible. But you would face certain amount of downtime, right, there, because you need to ensure that the data is moved properly. I would say about an hour or 2 hours but again, plugging a little bit here, if you want to do something like that, CS is the company. We do that day in and day out. That's our bread and butter. So if you
Yeah,
want
no, I fully understand. As far as I would recall, if it's an active implementation on infrastructure side, then you could do this without any downtime, right?
Again, that's the thing, right? For stateful, it's a problem because there's data involved. How, if it's active, you have data being stored at two places. How do you read and read and writes will become difficult. And then once you want to switch over finally to one, what would happen to the intermediary data, right?
Yeah, that's cool.
Have
That's a very good point. Yeah. Okay, that might be something that we need to follow up on at a later stage.
yes.
Good. Thanks. I think this was a very, very interesting session, Animesh. Very much in line with what we're trying to achieve in during automation days, is to kind of give you beyond the basics, and to show some really well thought and in-depth sessions. So I think you really managed to accomplish that. This is a topic that I think a lot of people are very, very interested in, or assuming that you're in the nerd domain that we are in. But it's a very well prepared, very useful presentation. So I want to thank you for being part of Automation Days. I'm definitely going to invite you back for next year.
My pleasure.
To host another technical session, because this is always very, very useful.
Yes,
so I'd like to thank you for for being part of our event today.
My pleasure. Yeah.
Good. I know that we are slowly but surely getting towards the end of our day, but not before we close our today's session with a very special keynote. And for my next and closing keynote, we have the managing director of the Art of Service, as well as the author of the Robotic Process Automation, a complete guide book. So I'm super excited that Gerardus Blokdijk will be with us this afternoon, and he is going to give us a keynote from automation dream to reality, navigating the enterprise automation journey with RPA and best practices. So stay tuned for the final keynote, which is going to happen in slightly over 10 minutes from now. And I really look forward to seeing everyone back for the last session of the first day of Automation Days 2023. Thanks, Animesh, for your time. And for everyone else, I'd like to see you back in the next session very soon.
Thank you so much. Thanks, everyone. Thanks, Jan. Bye-bye.